Assalamu alaikum. This is Kamrul Hassan, lecturer, Department of Mathematics, Milestone College. My dear student, I hope you are fine. Today I want to discuss about creative question, which is very important for your board exam. This is our creative question. Look at this. Question number A. The two equal force of magnitude S acting at an angle 120 degree. Find the magnitude of their resultant. And here, question number B, the three forces X, Y, Z are in equilibrium. Show that X is to Y is to Z equals to A cos A is to B cos B is to C cos C. And question number C is here. If three like parallel forces X, Y, Z act at the vertices A, B, C respectively, the line of action of their resultant passes through the point O. Then show that X cosec 2A equals to Y cosec 2B equals to Z cosec 2C. And look at this here. O is the center of the circle and A, B, C are three angular points and X, Y, Z are three forces. And now first one here, look at this question number A. Solution of question number A. Here look at this. Two equal force. When two forces are equal, then the resultant will be R equals to 2p cos alpha by 2. And here the value of two equal force is S and angle is 120 degree. Look at this here, alpha by 2. The resultant of two equal force, look at this, the figure here. Suppose this force is P and this force is Q and resultant force is R, and here this angle is theta and this angle is alpha. Look at this, the resultant of two equal force acting on the point bisect the angle between those forces. That's why we can write theta equals to alpha by 2. Here alpha by 2. That's why alpha by 2. Now look at this. Here two equal force and angle is 120 degree. So the solution of question number A, given the magnitude of two equal force equals to S and angle alpha equals to 120 degree, and angle alpha equals to 120 degree. So we know that the formula of resultant R equals to 2S cos alpha by 2. Here S means here two equal force. That's why 2S and cos alpha by 2. Angle is 120 degree. So we can write 2S cos 120 degree by 2. And here after this line R equals to 2S 120 degree by 2. So it's 60 degree. And we know that the value of cos 60 degree is 1 by 2. So R equals to 2S into 1 by 2. And after calculation it will be S, because here 2 and 2 it will be cancelled. That's why R equals to S. So r equals to s, and this is the answer of question number A. Now question number B. The three forces x, y, z are in equilibrium, then show that x is to y is to z equals to a cos a is to b cos b is to c cos c. And look at the figure. Here A, B, C are three angular points, and three forces x, y, z are in equilibrium at point O. At point O. And here we know that the Lami's theorem. If three forces acting simultaneously at a point along three different lines are in equilibrium, then the magnitude of each force is proportional to the sine of the angle between the line of action of other two forces. That's why we can apply here Lami's theorem. So here look at this. The three forces x, y, z are in equilibrium, and by applying Lami's theorem, we get here, look at the figure. Here x by sine BOC equals to y by sine AOC, and here z by sine z, this force, and it will be AOB. Look at this. Here this is the central angle and this is the circular angle. That's why it will be here x by sine BOC is the central angle, so it will be BOC equals to angle 2A, and here AOC equals to 2B, and here AOB equals to 2C, because the central angle always equals to 2 into circular angle. So that's why we can write here twice A equals to y by sine twice B equals to here z by sine twice C, and here after this line we can write, and we know that the formula of sine 2A equals to 2 sine A cos A. This is the formula of sine 2A. That's why we can write here x by 2 sine A cos A. Similarly y by 2 sine B cos B equals to z by 2 sine C cos C. And look at this here, 2 and 2 and 2, they are same. That's why it will be cancelled, and here x by sine A cos A equals to y by sine B cos B equals to z by sine C cos C. And here after this line we can write here. Now here sin A cos A. Now multiplying by A on numerator and denominator. That's why AX by sin A into A cos A. Multiplying by A equals to here by sin B into B cos B, and here multiplying by CZ by sin C into C cos C, C cos C. And now after this line, and here after this line we can write x by A cos A equals to y by B cos B equals to z by C cos C, because we know that here A by sin A equals to B by sin B equals to C by sin C. That's why we can write here x by A cos A equals to y by B cos B, and here z by C cos C. And after this line we can write x is to y is to z equals to A cos A is to B cos B is to C cos C, C cos C. And this is the required solution of question number B. Now question number C. If three like parallel forces X, Y, Z act at the vertices A, B, C respectively, the line of action of their resultant passes through the point O, then show that X cosec 2A equals to Y cosec 2B equals to Z cosec 2C. My dear students, look at the figure. Here O is the circumcenter, and here X, Y, Z are three forces acting at point A, B, C, and the resultant of the force passes through the point O, and here the force X acting at point A. So here the resultant of like parallel force Y and Z act at point B and C, along the line of action, lie a line AD and BC, and here D is the common point, So the resultant of Y and Z act at point D. So we can write here, let the circumcenter of triangle ABC be O, and three force X, Y, and Z act at point A, B, C of triangle ABC. Since the since the resultant of force passes through the point O and force X. Here look at this, force X act at point A. So the resultant of like parallel force so the resultant of like parallel force Y and Z act at point B and C must be acted lie on lines AD and BC, and here D is the common point, and here D is the common point. The resultant of Y and Z act at point D. That's why we can write here Y into BD equals to Z into CD. Look at this. Here force Y into distance of B and D equals to force Z into distance of C to D must be equal. So we can write here Y by Z equals to CD by BD, and here we can write, look at this CD. Here 1 by 2 into CD into H, and here 1 by 2 into BD into H, and this is the area of triangle. Look at this here, CD. Here CD into height AD means H into half. So that's why it's area of triangle ADC. Triangle ADC, and here area of here half into BD into H, it's a area of triangle ABD. This is the equation number 1. And here after this line we can write here again y by z equals to CD by BD. Similarly we can write here look at this triangle OCD by triangle OBD. This is the equation number 2. Now from two equation 1 and 2. From equation 1 and 2, we get here, look at this, y by z equals to its CD by BD equals to triangle ADC by triangle ABD equals to, here CD by BD equals to triangle OCD by triangle OBD. So that's why we can write here triangle OCD by triangle OBD. And now after this line, we can write y by z equals to, here triangle ADC minus triangle OCD, and here also we can write triangle ABD minus triangle OBD, and here it's, look at the figure here, triangle ADC minus triangle OCD, it's triangle AOC, must be triangle AOC, and here triangle ABD minus triangle OBD, that's why it will be triangle AOB, and here triangle AOC we can write here, it's 1 by 2 AOC, 1 by 2 OC into here OA into sine angle AOC. This is the area of triangle AOC, and here we can write 1 by 2 into triangle AOB, it's OA into OB into sine angle AOB. This is the area of triangle AOB, and here look at this, OC, OA and OB are equal because they are all radius of this circle, that's why they are equal. So these are equal, so we can write here y by z equals to sine, look at this, angle AOC equals to, it will be 2b, so we can write sine 2b by sine, here look at this, sine AOB means it's 2c, sine 2c, and here half and half it will be cancelled, OA and OA it will be cancelled, OC and OB it will be cancelled because they are equal. That's why we can write y by z equals to sine 2b by sine 2c, and here after this line, we can write y by sine 2b equals to z by sine 2c, and here y into 1 by sine 2b equals to z into 1 by sine 2c, and 1 by sine 2b it's cosec 2b, and here z into 1 by sine 2c it must be cosec 2c, and after this line we can write similarly x cosec twice a equals to y cosec twice b, and so we can write x cosec twice a equals to y cosec twice b equals to z cosec twice c, and this is the required solution of question number C. So we can write here shown. This is the required solution of question number C. My dear students, no more today. See you again in the next class.